This video is all about page 31 out of your math book. And it says, your mother has accelerated onto the interstate beginning a long road trip. And you notice that the low fuel light is on, indicating that there is a half a gallon left in the gas tank. So in this particular car, when that fuel light comes on, there's half a gallon of gas left in the tank. The nearest gas station is 26 miles away. So that's also important. Your mother keeps a log where she records the mileage and the number of gallons purchased each time she fills up the tank. Use the information in the table below to determine whether you will make it to the gas station before the gas runs out. You know that if you can determine the amount of gas that our car consumes in a particular number of miles, then you can determine whether or not you can make it to the next gas station. So let's go ahead and examine this table right here. This is the mom's gas record, and the X column represents gallons. That's the independent variable. And then the Y column represents the miles driven, and that's the dependent variable column. So this should hopefully make some sense. The miles driven depends on how much gallons are in the tank. Okay, so that's why this is independent and this is dependent. So the directions say find the constant of proportionality and explain what it represents in this situation. So as you should hopefully know, constant proportionality is basically just the unit rate. Whoops, I don't know why I'm writing unit rate. Sorry. Okay, so we're going to find the unit rate. And to find the unit rate, you should know that you got to go y divided by x to find unit rate. Okay, so I'm going to take this y value and divide it by 8, y divided by x, so 224 divided by 8, that's 28. So I took this x column, I multiplied it by 28 right here to get this corresponding y value. Okay, now I have to go 280 divided by 10, which is also 28. If I could type it in correctly. So far it's looking like it's going to be proportional, but you want to check every value in the table to make sure it's a proportional relationship. 112 divided by 4, because it's y divided by x, and that is also 28. So our unit rate, you know, when you go y divided by x, you can take any one of those values from the table because we know it's proportional, and I'm just going to pick this one, it doesn't matter. 112, and make sure you label it 112 miles on 4 gallons of gas. I'm abbreviating it. So to find that unit rate, I'm going to divide by 4, divide by 4. 4 divided by 4 is 1, so 1 gallon. And then 112 divided by 4, which we already did up here, is 28 miles. So that right there is the unit rate, and we need to explain what it represents in this situation. Okay, this means the car can travel 28 miles for every 1 gallon of gas it has. That says means. Okay. The next part of this problem says write equations that will relate the miles driven to the number of gallons of gas. So as I've shown you, you want to start off with writing y equals, and then you're going to leave a space right here for your unit rate times x. And since we do know the unit rate is 28 miles per gallon, we can write the 28 right there. And of course, I definitely always want you to label. So this x represents, well, if you forget, remember how we had labeled up here? It represents gallons. And then y, which is the dependent variable, if you can look up here, it's the miles driven. And I notice it says write equations. So another way that I can write this exact same thing is I can write it like this. I can write 28 times x equals y, which is the exact same thing. I just kind of reversed it. Okay. I also forgot to do something. I forgot to label that as the unit rate. And the unit rate was 28 miles per gallon. Okay? All right. So the next question, letter C, says, knowing that there's a half gallon left in the gas tank when the light comes on, will she make it to the nearest gas station? Explain why or why not. So I want you to take a second right now and think about what this right here means, that unit rate means, okay? So on 1 gallon of gas, she can go 28 miles. Well, how much gas does she have? She has half of a gallon left in the tank, and that nearest gas station is 26 miles away. Can she make it? Go ahead and write your explanation right here. Write yes or no and your explanation. I would like it in your own words. To kind of prove the point right here, I know that she's got half of a gallon left in the tank, half gallon. So I'm going to just write 0.5 because that's a half, or I can write 1/2, which is the same thing. And I'm going to multiply that by 28 just to continue the pattern. So in half of a gallon in the tank, I want to know how far can she go. So I'm going to go 0.5, 5/10 or 1/2, same thing, times 28, and I get 14. So on half of a gallon of gas, she can only go 14 miles. That gas station is only 26 miles away, and unfortunately, she's not going to make it. So looks like you're going to have to get out of the car and push. So no, she won't make it. She can go 28 miles on 1 gallon. So if there's only a half a gallon left, she can only go 14 miles. The gas station is 26 miles away, and I know that because it says right there. She'll run out of gas because she won't make it. Okay, letter D. Using the equation found in part B, determine how far your mother can travel on 18 gallons of gas. So it says solve the problem in 2 ways, once using constant proportionality and once using an equation. So I'm going to show you a couple of ways actually, because I want you to be flexible in your thinking, okay? So I'm going to show you just one, the first way I'm going to show you using the equation. And luckily I have it written right up there, so it's going to be really easy to kind of just like use it as a resource. And we're curious about how far she can travel on 18 gallons of gas. So it says 18 gallons of gas. Is 18 going to go under gallons, or is the 18 going to be substituted in for the miles driven? Well, since it says 18 gallons of gas, I'm going to substitute it where it says gallons, because that's where you would plug it in, okay? So that equation, I'm just going to rewrite it. Y equals, because we don't know the miles driven, keep the unit rate, and then instead of writing the X right there, we're going to substitute that 18 right there, okay? So Y would equal 28 times 18, which is 504. And that would be miles. That's how far she can go on 18 gallons of gas. So that's using the equation. Now I'm going to show you using a proportion, or equivalent fractions. So using proportions. So the unit rate, like we had found, was 28 miles per 1 gallon. And we are looking at 18 gallons of gas. So since it's gallons, that's going to go in the denominator to match right there. And all I got to do is I have to multiply 1 by 18 to get 18. And I have to go 28 times 18 to get 28 times 18, I get 504 miles. Okay, see how we could have used the equation and proportions? And then let me show you just a third way, just for fun. Let's use the table. using a table. So in particular, that table right there. So let's see here. How would I do this? I'm going to go ahead and I'm just going to write it in the table over here. Actually, no, I'm not going to do it there. I'm going to do it down here. Sorry. So we got gallons, which is X. And Y is miles. And I'm just going to take any value in the table that corresponds to each other. So I'm going to go 10 and 280. And we know that our unit rate was 28, so we had to multiply that X value by 28. So when it says 18 gallons of gas, that 18 goes under the gallons. So I just have to go 18 times 28. And 18 times 28 is 504 miles. Okay? So see how you can be flexible in your thinking when it's asking you to solve a problem. A fourth way that we could actually do this is by graphing these points and then looking at the graph. But unfortunately, there's really not enough room for that, okay? So let's go ahead and look at E. Using the constant proportionality and then using the equation found in part B, determine how many gallons of gas would be needed to travel 750 miles. So again, I'm going to follow the same format from D, where I'm going to show you 3 different ways to do that, okay? So the first one is using the equation. And I see here that we're concerned about traveling 750 miles. So I'm going to go ahead and look up here at the equation. And it says 750 miles. Does that get substituted in for gallons or for miles? Well, it would obviously be substituted in for miles because it's labeled miles and this is labeled miles. So instead of writing the Y, I'm going to write 750 equals, keep the same unit rate, and keep that variable of X because we don't know how many gallons of gas are needed to travel this many miles. So we're going to solve for that variable. We're going to solve for that unknown of gallons. So I'm going to build it. Start with X and we multiplied it by 28. So the inverse operation multiplying by 28 is to divide by 28. So that's what we're going to do to both sides of that equal sign. 28 divided by 28 is 1. 1 times X is X. And then 750 divided by 28, I feel like that's going to be a decimal. Okay, let's go ahead and round to the nearest hundredth. So that's the hundredths place. The number behind it in the thousands place is 5 or above. So this 8 turns into a 9. So it's 26.79. 26 and 79 hundredths gallons would be needed to travel 750 miles. Okay, the next way I'm going to show you is using proportions, you know, 2 equivalent fractions. And let's see here. I'm going to just start with that unit rate. We know that the unit rate is 28 miles per gallon. And we're concerned about 750 miles. So it's miles, so I'm going to put that in the numerator. And we need to figure out this value right here. Okay? So to go from 28 to 750, I had to go, basically, I'm going 750 divided by 28 to figure out that multiplier, okay? So 750 divided by 28 is this. So that's what I'm going to multiply by. I'm going to keep it in my calculator because that's like, it's more precise than me rounding. But basically, I'm just going to write times 26.79. So I got to multiply this 1 gallon by 26.79. So that times 1, boom, is 26.79. So we get 26.79 gallons. So 26 and 79 hundredths. Sorry for not being mathematically sound. I'm not even making any sense. Mathematical sounding in my sentence. Okay, so see how we get the same answer? Now the third way I'm going to show you is using a table. And not just any table. It's this table up here where I get those values, okay? So we got X for gallons. I'm abbreviating because I'm running out of room. Y for miles. And I could pick any value on the table because I know it's proportional. Let's go with 8 and 224. 8 gallons, 224 miles. And we knew that to go from 8 to 224, we multiplied it by 28. So I'm just going to continue that pattern here. But we're concerned about 750 miles. Since this is labeled miles, I'm going to put the 750 right here. So to work backwards, instead of, I'm supposed to multiply this by 28, but since I don't have this value, I have to divide 750 by 28. So 750 divided by 28 And we get that. I'm rounding to the nearest hundredth, 26 and 79 hundredths gallons of gas are needed to go 750 miles.